Alright, today's lesson is going to focus on the study of polynomials, and two important things about polynomials that we're going to work on today. First thing is understanding vocabulary and understanding the parts of a polynomial function, and then the second thing will be a set of skills which involves adding, subtracting, and multiplying polynomials. First thing to make sure you are aware of, exponents must be positive integers in order to be considered a polynomial. So if you have things like x to the 3/2, that's not going to be a polynomial because your exponent, while it's positive, is not an integer. Likewise, if you have things like x to the -4th, that is not considered a polynomial function because even though this is an integer, we've got a negative sign there. So you have all of this vocab in your packet. No need to write it down, but you might want to make some little notes next to it. We're going to go through one example together. So the first thing is to understand what the terms of a polynomial are. Terms are groups of numbers and variables that are separated by addition or subtraction. So if we were to count the number of terms in this polynomial up here at the top, we've got 1, 2, 3, 4, 5 terms in our example, because those are 5 groups of numbers and variables that are separated by addition or subtraction. Next, we can talk about the degree of a polynomial. First, you want to talk about the degree of each term. So it's the sum of the exponents. Here we have an exponent of 4. This would make an exponent value of 5, this one of 8, this one of 0, and this one of 1. So each term has its own degree value, but then we name the overall polynomial by the highest degree of any one term. So we said this term had a degree of 8, so we would say that this is an 8th degree polynomial. So again, you can name each term, but then you name the whole polynomial by the term with the highest degree. A coefficient is a number in front of the variable or variables in each term. So we have a coefficient of 3, -5, 7, 3, and -19. So then more specifically, we can talk about a leading coefficient, which is the number in front of the highest degree term. Well, we decided that this one right here was our term with the highest degree, which means our leading coefficient would be 7. Keep in mind that the leading coefficient is not necessarily the coefficient that's written first, okay? But it's the one that is tied to the term with the highest degree. So the last thing to talk about is writing the standard form of a polynomial, and that standard form is when the terms are written from the highest to lowest degree. So in this case, we would want to write 7 x to the 3rd y to the 5th minus 5 x squared y to the 3rd plus 3x to the 4th minus 19y plus 3. So we're going from highest degree to lowest degree, which gets us in standard form. Now, please notice if your polynomial is in standard form, now your leading coefficient is the one that leads out in front. Alright, so state the number of terms, the degree, and the leading coefficient of the following. So first thing, let's look at the number of terms. We'll use a t to represent that. We have 2 terms that are being separated by addition. The degree of the highest term is going to be this one right here, and it has a degree of 1, which we would also call that a linear polynomial. And the leading coefficient, the number that is going with the term that has a degree of 1, is going to be 3. This next one, we're in standard form. Okay, so first thing to notice and think about, the number of terms we have are 3. Our degree of this polynomial, so if we look at the term with the highest degree, it's going to be this one right here. We have a degree of 3, and the coefficient that is stuck to the term with a degree of 3 is the 4. Moving on, this next one, if we look at if it's in standard form, it is, so we're good. It'll just be easier to look at that way. We have 4 terms. Our degree is, let's see, this one has a degree of 4. This one would have a degree of 3, because there's an understood 1 there. This one would have a degree of 2, and this one would have a degree of 0. So our degree is 4 because of this term right here. And our leading coefficient, even though there's no coefficient written, we can assume that there is an understood 1 as our leading coefficient. Last one. Looking here, we're not quite in standard form because we've got to the 4th power. This would be a 5th degree term and then a 0. So I'm going to first rewrite this just so that it's a little bit easier to read all the different pieces. You do not have to. If you can remember that your leading coefficient doesn't have to be the first thing written, then you're in good shape. But we'll say that we have 3 terms. The degree is going to be 5, and our leading coefficient will be negative 12. Alright, that takes care of our vocabulary for polynomials. Now we're going to move on to our skills. First set of skills is adding and subtracting polynomials. So that just means to add or subtract like terms that have the same variable, so things with x's or things with y's, things with the same combination of the sort, and the same degree. So if you remember from first year algebra, you can add things that have x to the 1st power together, things that have x to the 3rd power, combining like terms. Something to be careful of with subtraction. For instance, in this problem we have this polynomial subtracting this polynomial. When you subtract, you want to make sure that you distribute this negative sign to both terms. So I'm going to rewrite this as 3x squared minus 2x plus 5 minus 2x squared minus 4, just so we take care of that subtraction. Now, I need to combine like terms. Well, this has an x squared and this has an x squared. So 3x squared minus 2x squared is going to be just 1x squared. I don't have anything else that has a linear power, just x to the 1st, so I'm going to say this is minus 2x. And then this one is a constant and this one is a constant, and 5 minus 4 gives me a positive 1. So when I do this subtraction problem, my final answer is x squared minus 2x plus 1. Alright, next skill is going to be to multiply with polynomials. Multiplying means use the distributive property and then do what we did with adding and subtracting by combining like terms. So the distributive property when you've worked with binomials, so you've had things like x plus y and a plus b, you were taught to FOIL, which means first, outside, inside, last. But if you look at what you really did there, you were distributing. You distributed the x to both the a and the b, and you distributed the y to both the a and the b. So the same thing is going to apply, it's just that we can't use our little acronym of FOIL. Instead, you're just going to take the first term, multiply it with the first term of the second polynomial, so 3x squared times x squared is going to give us 3x to the 4th. Then 3x squared times 2 is going to be 6x to the 2nd. Then I'm going to move to this term and do x times x squared and x times 2. So this is going to be x to the 3rd plus 2x. Then finally I'm going to take negative 5 and distribute it. So we'll say negative 5, x squared, and negative 10. So again, it's just using the distributive property to make sure that everything gets multiplied correctly. Then we're going to combine like terms. Well, this is the only thing that has an x to the 4th, so that's just going to stay 3x to the 4th. Here I have 6x squared minus 5x squared, so that's going to be plus x squared. I have an x to the 3rd. I have a 2x. And I have a negative 10. Last thing, you might want to write your polynomial in standard form. Usually on a test or a quiz, it will tell you what form we want it in. But good rule of thumb is to get it into standard form. So again, write your terms from highest degree to lowest degree. Final answer. Okay, when you are dealing with multiplication of polynomials, there are what we call special products, or things that show up often, that the sooner you kind of recognize the patterns, the easier it will be. You can always take the time to multiply it out, and that's fine, but you'll start to see similar things happening. So the first one is if you have a plus b and a minus b. So again, it doesn't have to be a's and b's. They could be different terms with different variables and all of that stuff. But what you're going to do here is FOIL, or distribute. So a times a times negative b times a, b times negative b. And you'll find that you get a squared minus ab plus ab minus b squared. But what happens in the middle, negative ab and positive ab go away, and you're left with just a squared minus b squared. So likewise, if you ever start with this and you need to factor, it will equate to that one. Next thing, a plus b quantity squared does not mean take a to the second, b to the second. Raising something to the second power means take that polynomial and multiply it by itself. So now when we FOIL, we get a squared plus ab plus b squared. This time the middle terms aren't going to drop out, but you can add them together because they are like terms. So we'll get a squared plus 2ab plus b squared. Final answer. Okay, again, you did not just take a to the second, b to the second. Next thing, a minus b to the second. We're going to say a minus b times itself. Which is going to give us a squared minus ab plus b squared. So when you take a negative times a negative, you get a positive. In the middle then, this is going to simplify to minus 2ab plus b squared. These two things are equal. Last type of special product that you want to be aware of is something that we call SOAP. Okay, so SOAP stands for same, opposite, always positive. This is something you learned in your second year algebra course. If you are trying to factor a polynomial, that can be viewed as a difference, okay, subtraction there, or a sum, addition there, of perfect cubes, then you are first going to want to figure out what is being cubed. So, in this first term, a is what's being cubed, and the second term, b is what's being cubed. And then you want to set up two sets. The first one's going to be a binomial, the second one's going to be a trinomial, and you're going to follow SOAP. So, same sign, this was a subtraction sign, opposite sign, so this was subtraction, which means this one is going to be addition, and then always positive. The last sign is always positive. Then you want to go through and you want to fill in your structure of the factoring. So we had a and b, which means in this first set we get a minus b. Then we're going to take a and square it, take a times b, and then take b and square it. Same thing if you have a sum of cubes. You can set up your two sets. We're going to have the same sign, so positive, opposite sign, negative, and then always positive. We're going to have a, b, a squared, ab, and b squared. So, I know there's not an example on your notes, but we're going to make one up here real quick. If it wasn't as simple as just a to the third and b to the third, let's say this was 8x to the third minus 27. You've got to do a little bit of work to figure out what's being cubed. Well, here, this is the same thing as 2x to the third. And this would be the same thing as 3 to the third. In which case, our a and our b are 2x and 3, respectively. So when you set all of this up, we're going to have same, opposite, always positive, a, b, a squared, a times b, and then b squared, which is 9. Okay, so again, that was a, and this one is our b value. So that's what's being plugged into our formula. If you know the structure, you just got to go through and plug in the numbers that you have in your given polynomial. Alright, make sure you know your vocabulary when we talk about terms, degree, and coefficients. And make sure that you can add and subtract and likewise multiply all of your polynomials.